All right, so you made it to the second part of my review. I don't know that this is easier or harder, but I think the problems might be a little more advanced, but it shouldn't keep you from understanding them. Hopefully, there isn't anything on the review that after we do a couple problems that you'll feel intimidated by when you go to take your placement test. So, this problem, when I first was exposed to something like it, I wasn't exactly sure what to do because it just looks different than the typical kind of solve for X problem that I'm used to. And in this problem, problem 12 in my review, we need to get the t by itself. And in order to get the t by itself, because everything on the side of the equation along with the t is being multiplied by the t, I have to divide by everything in front of the t to get t isolated. But before I do that, I'm going to clear this parentheses. So as I get into 12a, I'm going to clear the parentheses. I might actually leave the parentheses here temporarily. But I'm going to rewrite the left side so it doesn't have that fourth power in front of the parentheses. And I do that by raising everything inside the parentheses to the fourth power. So the 2, I'm going to raise it to the fourth power. And because the x has an exponent, and because there isn't any adding or subtracting inside the parentheses, I'm going to multiply the exponent of the x by 4. And then for the y, I'll raise it to the fourth power as well. Now I'm going to write a line, and I'm not going to write a parentheses anymore. I've kind of took the real need for the parentheses away when I got rid of that exponent of 4. 2 to the fourth power is 2 times 2 times 2 times 2, and I'm going to write 16 for that. For the x exponent, I'll multiply the exponent to get x to the 8th, and then I'll have y to the 4th and my t that I'm trying to solve for. This makes it so it's not going to be too bad to get t solved for. Like I said, everything on the side of the equation that has the t is being multiplied by the t. So to detach it from the t, I need to divide. And so if I divide both sides by 16 x to the 8th, y to the 4th, that will make it so the t is by itself, because on the left side, everything cancels. I'm left with the t. And then on the right side, I'm going to divide 32 divided by 16. I could do that in my head. I suppose you could do long division if you needed that. And I'll get a 2 for the number part of the right side. As in terms of the variables, when you're dividing, you subtract the exponents on the variables. So for the x, I'm going to take 15 and minus 8 and wind up with x to the 7th power. And for y, I'm going to take 7 minus 4 and wind up with y cubed. So the answer to 12a should be 2x to the 7th y cubed. And I can always check to make sure I haven't messed anything up. So I look to my little key and I look for 12a, assuming I could actually find it. And 12a says it's supposed to be 2x to the 7th y cubed, exactly what I have, so I feel good about moving on to the next part of 12. So my hopes now would be that you give this a go by yourself. Should have exactly the same vibe as part A, and if you get it done, have the right answer, don't watch my video. If you don't get the right answer, I feel like watching the video, watch it. So I'm going to do just like I did for part A. I'm going to cube the 2, and I'm going to cube the x to the 5th and y squared, and for the variables, I'm going to multiply the exponents to do my cubing. So I can rewrite the left side like 2 cubed x to the 5 times 3, y to the 2 times 3. And I can leave temporarily the right side 24x to the 19th, y to the 10th. 2 cubed is 2 times 2 times 2, which is 8. Now I'm going to drop the parentheses. I really could have dropped the parentheses on my first step, but I just didn't. For the x's, I multiply the exponents as well as the y's. I'm multiplying the exponents. And now I'm going to divide again, just like I did in part A. And this time I'm going to divide by 8, x to the 15th, y to the 6th. There's lots of nasty things that might happen that might cause you to get negative exponents. I don't remember getting exposed to negative exponents too heavily on the Accuplacer test when I took it. So on the left side, my dividing is going to cancel everything. It's going to leave me the t. And on the right side, 24 divided by 8 is 3. And for the variables, I subtract their exponents. So I get x to the 19 minus 15 and y to the 10 minus 6 power. And so my answer, because I'm asked to solve for t, I'm going to write t equals, I'm going to write 3x to the 4th, y to the 4th, and check myself real quickly, 3x to the 4th, y to the 4th. I know I did well there. So that's not particularly hard, but it might be, if you've never seen anything quite like that, it would be hard maybe just to figure out what to do. But maybe since you've seen this, if you see it again, you'll know what to do. 13 isn't particularly hard, but it's another one of those questions that you may have not thought about a problem like this before, nor seen a problem like this before. Maybe you've even talked about symmetry, but maybe not symmetry with function notation. So in this problem, I'm told there's a graph of a function that's symmetric to the line x equals 3, which means the graph of whatever I'm concerned with, the line x equals 3 works as a mirror essentially, and every point to the left of the line x equals 3 has a point that's kind of its mirrored image to the right side of the line x equals 3. So I'm going to draw the line x equals 3. I'll draw it as a dotted line just in case my red doesn't look different than my black, so it doesn't look like the y-axis, because I have an y-axis here and an x-axis there. So there's my line of symmetry, and I'm told that f of 2 equals to 5, which means this graph passes through the point 2, 5, because in function notation, a number or letter inside a parentheses refers to an x value, and a number to the right of an equal sign refers to a y value. So this f of 2 equal to 5 gives me the point 2, 5, and because of this line of symmetry, I know there's a point that's exactly on the opposite side of this line, the same distance away from this line, that's also part of this function. So the point of symmetry would be this point 4, 5, because it's exactly the same distance away from the line x equals 3, which is my line of symmetry. That's convenient because I'm asked to find f of 4, and in function notation, this is asking me to find the y value of the point that has x equal to 4, because in function notation, a number or a variable inside a parentheses refers to an x, and a number or a variable to the right of an equal sign represents a y. So my answer, without any algebra, is just with understanding to 13a, is I'd say that f of 4 equals to 5. 13b has the exact same trick. I'm going to draw a Cartesian coordinate system, draw my line of symmetry, plot the point that's implied by the function notation, plot the point of symmetry, and that's going to give me the answer to the question. So for part B, I'm told the line of symmetry is x equal to 6. Ultimately, I'm asked to find f of 9, so I'm making my x-axis go to 9. And I'll draw my line of symmetry that goes through 6 on the x-axis. Again, I'm making it a dashed line just in case my red doesn't look so red. I don't want it to look like the y-axis again. And the point that's implied by the given information, f of 3 equal to 7, refers to the point 3, 7. And I get a little bit lazy on my y-axis, but I hope that you can hang with that. And this point is 1, 2, 3 away from my line of symmetry. So if I go to the right of my line of symmetry, 1, 2, 3, this is the point of symmetry. Because the graph is symmetric about x equal to 6, if I have a point 3 units to the left of the vertical line, I need that's a mirror point to the 3 to the right of it. And this has a point, its x value is 9, its y is 7. So the point of symmetry is the point 9, 7. And in function notation, I put the x coordinate of the point in the parentheses with the function name, and the y coordinate of the point to the right of the equal sign. That's going to be my answer to part B. And even though you don't see me checking these, I'm actually checking them to make sure I did f of 4 equal to 5, f of 9 equal to 7. Just want to make sure that I'm not writing down anything that's wrong. All right. Sketch a graph of a logarithm. That's a bit challenging. I generally, when I am asked to graph a logarithm, I go through the same steps regardless of how simple or complex my graph is going to turn out looking. And my steps to graph any logarithm are these. So to graph a log, I go step 1, change, if you have function notation, change it to the letter y, or the variable y. So I'm going to change from function notation to xy notation. Specifically because it just makes the algebra that I'm going to do a little bit easier. So my step 1 is I'm just writing y equals the log base 3 of x. And then 2, I'm going to write without a log. I'm going to rewrite, how about this? Write without a log that is, I'm going to write in exponential form. To do this, I'm going to scratch out the logarithm. And I'm going to create an exponential equation, which is an equation that has an exponent equation means I'm going to have an equal sign. I'm going to create an equation with an exponent. The 3 is going to remain low. It's going to be called the base. It's the base in the original problem. And it's going to be the base in my exponential problem. So on the right-hand side, I'm going to write a 3. And now I'm going to switch the role of the x and the y. The y is going to become the exponent, and the x is going to go to the left of the equal sign. That's the equation that I'm going to wind up graphing, and it will have the same graph as the y equals the original problem. Step 3 is I'm going to do my table of values. And every time I graph a logarithm, I start with the exact same table. And the thing that makes it a little bit, strange is that I fill up my y column first. And for every logarithm graph that I do, I put the numbers 2, 1, 0, -1, and -2 in the y column. And I do algebra to find the x's. So that's what I'm about to do now. So for the first one, I'm going to go x equals, and then I'm going to plug a 2 in for that y. I'll get x equals 3 squared, and 3 squared is 9, and as a point, that's going to give me the point 9 comma 2. For my second value of y, which is 1, I'm going to put a 1 in there, and I'll get x equals 3 to the first, and 3 to the first power is 3, and that's going to give me the point 3, 1. Then I'm going to plug in 0 for that y, and get x equals 3 to the 0, and anything to the 0 power is 1, so I'm going to say that x is 1, and that gives me the point 1, 0. And then I'm going to do x equals, change that y to negative 1, and I get 3 to the negative 1. And 3 to the negative 1 power is 1 over 3 to the first power. So that's going to give me 1/3. And that's going to give me the point 1/3 comma negative 1. And then my last value, I'm going to go x equals 3 to the negative 2 power, which is 1 over 3 squared, which is 1/9. So my last point is the point 1/9 negative 2. If I'd never graphed logarithms before, then I might make a bigger table. I might make my table go from +4 to -4 and get maybe an extra 4 points in there, just because the more points that you get drawn, probably the more comfortable you can be with the graph that you're showing or creating. So the best I can, I'm going to make a graph, and I think I'm going to shove this on a different sheet of paper just because I didn't think it's going to fit so well. So I'm going to make my coordinate system, and I'm going to make it kind of right heavy. So here's my x-axis. I can call this a y-axis, or I can call it an f of x-axis. Doesn't matter. The test question would be multiple choice anyways, so it's not like they're going to peek at my work to see if I've done things as nicely as a teacher might like. Now the best I can, I'm going to plot the points. So the first point I have is a point 9,2. Then the point 3,1. Then the point 1,0, which is the x-intercept that we were asked to show. So this is the x-intercept. And then the point 1/3 negative. I really didn't plot 1,0 that perfectly. I guess I should have plotted 1,0 right there, being that it's not the point 2,0. Sorry about that. And then I'm going to plot the point 1/3 comma negative 1. 1/3 is about there. It's a third of the way between 0 and 1, and negative 1 is down there. So that's a reasonable representation of the point 1/3 negative 1. And then 1/9 is even closer to the y-axis. It's 1/9 of the way between 0 and 1. It's slightly to the right of the y-axis, and then I'm down at -2. And if you've graphed logarithms, you know that they usually have a vertical asymptote, meaning it's a vertical line usually that the graph gets really close to, but it doesn't actually touch or cross. I don't know that the homework answer, or the answer that I have on my key, is much better than this. If you get this accurate of a graph on the placement test, you'll be able to figure out the graph no problem. If I look at my answer to 14A, you'll see it looks a heck of a lot like this. I see the point 1,0, I see the point 3,1. There's also the point 9,2 that wasn't shown on this, and some of my fraction points didn't show up on this either. So this and that say the same thing. This with a little more detail is probably drawn a little bit nicer. But if you can do that well drawing a logarithmic graph, I think you'll be completely fine. Hope you'll be fine when you get to the placement test. So I'm going to move on to part B. Hopefully you're giving that a go without me. I'll go through the same procedure. First thing I'm going to do is change from function notation to y. So this is my step 1. I'm going to introduce, I'll say XY notation. And that just makes it easier to do the step 2. If I left the function notation, it's tough to do this next step. So step 2, I'm going to write without the log. In exponential form. And again, to do that, I scratch out the log. The 2 is going to remain the base. So scratch out, remain the base, and I switch the x and the y. And what that gives me, on the right side, the 2 stays low, the x moves from the right side to the left side, the y moves from the left side to the right side and becomes the exponent. Now for step 3, I'm going to make my table of values, I guess in graph. And every single time I graph a logarithm, I make the same starting table. I use in the y column 2, 1, 0, -1, and -2. For each blank in the x column, I'll just take this y and plug it in here. So for the first x, I'm going to go x equals 2 squared, just changing that y to 2, and that will give me 4. And that will translate to the 0.42. And then I'll go x equals 2, and I'll change this y to that 1 and get 2 to the first power, and anything to the first power is itself. So that's going to lead me to the 0.21. And then I'll continue that. I'll get x equals 2 to the 0 power. Anything to the 0 power is 1. So that gives me the 0.10. And then x equals 2 to the -1 power, which is 1 over 2 to the first power. So that's going to be the 0.12, -1. And then last, x equals 2 to the -2 power, which is 1 over 2 squared, which is 1/4. And the fifth point that I get is the 0.14, comma, -2. I'm going to try to just scrunch the graph in here. I'll make it kind of right heavy as opposed to up and down or left heavy. So here's my x-axis, my y-axis. On my y-axis, I need to go up to 2 and down to -2. And on the x-axis, I only need to make it out to 4. And then the best I can, I plot the points. So the 0.42 is about there. The 0.21 is about there. The 0.10, which is my x-intercept, is there. 1/2 is about there, down 1. It gives me the 0.12, -1. 1/4 maybe is about there, and 1/4, -2 seems decently plotted. I'm going to make my graph go out to the right, off to the right. It keeps going up forever and just slowly goes up, but to the right of the y-axis, there's always a microscopic gap between the graph and the y-axis. The graph actually never touches the y-axis. We say the y-axis serves as a vertical asymptote. And when I look at my picture here, here's the 0.12, -1, 1, 0, 2, 1, and 4, 2. All the points that I have found. In addition, I have the 0.14, -2 displayed as well. So I feel good that my graph is correct because it matches my key as perfectly as it can possibly match my key. And again, the test is a multiple choice test, so as long as you can distinguish between the correct graph and the incorrect graphs, then you're fine. And the incorrect graphs won't be even remotely close to this, so that if your graph is just reasonable, you're going to be completely fine. Fifteen's a friendly problem, asking me to simplify something with a fraction exponent. Be nice if I had a calculator, but I don't. Any problem that has a fraction exponent can be turned into a radical. And the radical form of this, I'm going to write my radical symbol, and the denominator of the fraction exponent is going to become the index, and everything else is going to go under the radical, and we call it the radicand. So this is the second root of 25 cubed. Hopefully you remember with radicals that if a number is not written as an index, it's an implied 2. So the original rewrite can be improved upon. And I can think of that as the square root of 25 cubed. And the nice thing about this is you have your choice. You can cube 25 first, or you can square root and then cube. I'm going to square root the 25 and then cube, just because it keeps the numbers smaller. When I square root the 25, I get 5. And when I cube 5, I get 5 times 5 times 5, which is 125. I almost think that this wouldn't be a problem where that little checkbook calculator would pop up. It would just assume that you could actually do this yourself. I should check, just because I'm shooting this video by myself this morning, and I make gobs of mistakes. So I checked 14a, 14b, I just did 15a. 15b is actually the same style of problem, maybe a little bit more confusing because of the 3 in the denominator. But just like I did 15a, I'm going to write it in a radical form. So it's going to be the cube root of 27 squared. And then the first thing I'm going to do is I'm going to do the cube root of 27, and then I'll square, as opposed to squaring and then cube rooting. It's one of the rare times that orders of operations is kind of interchangeable. So when I cube root the 27, because 3 times 3 times 3 is 27, the cube root of 27 is 3, and then I'll square the 3, 3 squared is 9, and my answer is 9. If you're that rusty on your, exponents and radicals, college algebra might not be the place for you. You might want to think about starting in intermediate algebra, because they hit this really hard in intermediate algebra, and you'll be better at it than you might be now. All right, 16a. When you take the Accuplacer, I took it 2 times and it was completely different both times, but on one of the times they had me solve an inequality, and the answers, again, were multiple choice. The answers were graphed on a number line. When you look at my answer to 16a, I write x is greater than -8. This is just because I don't know how to make a number line solution. So you need to be familiar with number line solutions and how they relate to just solutions written in inequality form. And I'll talk about that a little bit, I guess, as I do this. So I need to solve for x. Means I need to get the x's on one side, the numbers on the other. If I do what most students would do, probably minus 5x from both sides to get the x's on the left side, and add 10 to both sides to get the numbers on the right side, I'm going to create a need to flip the inequality, but not yet. Adding and subtracting with inequalities never causes the direction of the inequality to change. So my first step, I'm going to leave the less than sign a less than, because all I've done is added and subtracted. 3x minus 5x, those have opposite signs. I subtract and take the sign of the larger and get a -2x. On the left side, the -10's cancel. On the right side, the 5x's cancel, and 6 plus 10 is 16. anytime you multiply or divide by a negative, and only multiplying and dividing, not adding or subtracting, you have to switch the direction. So if I was dividing by a positive 2, I wouldn't switch the sign from a less than to a greater than. But because I'm dividing by a negative 2, I have to switch. So this now is going to become switched. And the reason I'm switching it is because that is a negative. And that's the only time. If you multiply or divide by a negative, you switch the sign. On the left side, my negative 2's cancel. I'm left with an x. I'm switching the less than to a greater than. 16 divided by negative 2 is negative 8. This is the answer written as an inequality. And that's all I asked for. But it could happen that on the multiple choice answers that you might be presented with, you might see a number line answer. And the Accuplacer test writers for number line answers, they put open circles above the target number or the number that's in the answer if there's not an or equal to. And if this said greater than or equal to, there'd be a closed circle there. And then for if the variable's on the left, greater than is an arrow to the right, less than is an arrow to the left. So that would be the answer written on a number line. I didn't ask for that, but it's definitely something you need to remember. (16b), it got a little ridiculously large here. Sorry about that. I'm going to minus 8x and minus 12 from both sides. When I minus 12 from both sides, it gets the numbers on the right side. And when I minus 8x from both sides, it gets the variable x on the left side. So doing that, 12 minus 12, the 12s cancel. Negative 4 and negative 8x, because those have the same signs, I add the numbers and keep the signs negative and get a negative 12x. Keep my greater than sign, because I only switch the direction of the sign if I divide or multiply both sides by a negative number. On my right side, the 8x's cancel. 24 minus 12 is 12. And now I'm going to divide, and because it's a negative I'm dividing by, I have to switch. If that was a positive 12 I was dividing by, I wouldn't switch. I only switch if I'm dividing by a negative. So for my answer, negative 12 divided by negative 12, those cancel, leave me the x. I switch the greater than to a less than. 12 divided by negative 12 is negative 1. And again, you need to be able to prepared to identify answers that are written in multiple choice in different formats. And the format, the number line version of that answer would look like that, or like a minimal number line answer will look like that, where you'll have an open circle on the negative 1 and an arrow going to the left because if the variable is on the left, less than goes to the left, greater than goes to the right. I just checked my answer without showing you, and it's completely correct. 17 is another one of those problems where it's not particularly hard, but if you've never seen it before, then you might not understand it at all, and that's completely understandable. So hopefully I do something that makes it tolerable, and you don't mind it so much. So this problem says that there's a graph that has a period of 4, which means every 4 it repeats itself, and I can kind of see that. I can see this whole graph. Like here I would call one period of the graph. Between here and here I see kind of the picture. And why I say it's a period of 4, because this goes from negative 1 to 0 to 1 to 2 to 3. That's 1, 2, 3, 4. I get a stamp. And then from 3 to 4, 5, 6, 7, I get another stamp. So this graph repeats every 4, and I'm supposed to figure out what happens at 17. Well, I certainly could just keep drawing. I can't draw so well, but I think I can get this well enough. So this is 11, then I'm at 12, 13, 14, 15. I get the whole stamp again. So I'd go here. At 15 would be my next, post here, which means from 14 it would come down like this, and then this would go up like that. And then I just need to do one more stamp. 16, 17, sorry about the crappy writing, 18, 19, get another thing, go up, up. So it looks to me like at 17 I'm at a high point, and the high point of this graph looks like it's at 5. So for my answer I would say f of 17 equals to 5. The better way to do that is to take the number 17 and not even worry about the graph and progressively subtract the period from it. So to figure out that the graph looks like this and that the y value above 17 is 5, I would do this. I'd go 17 minus 5 is 12. 17, I would go, if I wasn't being stupid, I'd go 17 minus 4 is 13, which means at 13 I'm going to get another high point, but that wasn't given to me. And then 13 minus 4 is 9. The graph at 17 is going to be the same as the graph at 9, which is a high point, which would tell me at 17 my y value is 5. If I subtracted 4 again and did 9 minus 4, I'd give a 5. That says the graph at 17, as well as the graph at 13, as well as the graph at 9, as well as the graph at 5 are all high points and their y values are 5. This is just asking me to find the y value that corresponds to the x value of 17, and the slickest way to do it, because the period is 4, is just to take that x value, subtract 4 until you can locate that x value on the x-axis, go up and find the y-axis that corresponds. So if I'm doing B to find f of 15, I'm not going to draw my picture. I'm just going to go 15 minus 4 is 11. Actually, I can find 11 right there. The y value that corresponds to 11 looks to be negative 1. That's going to be the answer to this. Just to make sure I didn't mess up, let me take this 11 and go minus 4 and I get 7. Here's 7 and the y value at 7 is negative 1. If I subtracted 4 again, I'd get 3, and the y value at 3 is negative 1. So at 11, 7, and 3, which are all 4 apart, and 15, the y value should be negative 1. My answer to part B should be f of 15 equals negative 1. And let me see. Check, check, check. Make sure that I'm checking these along the way, because you hate to write down the wrong answer on a video and it's forever wrong. Okay. So binomial expansion. I'm using the binomial theorem to expand this binomial. And when I expand something to the 5th power, if I write down every term, it's going to have 6 terms. And I want to get the 4th of those 6 terms. I'm probably going to wind up getting most of the 6 terms, and I'll just pick out the 4th term. So in order to expand a binomial that's not a square, I usually draw Pascal's triangle. And Pascal's triangle, if you've never seen it before, you might have to poke around the internet to read about it, but I don't want to spend gobs of time doing Pascal's triangle creations. I need to do Pascal's triangle until I get to the key number. In this case, is the 5th power. So this is the row of the Pascal's triangle that I'm going to borrow. And so now I'm going to take the numbers from Pascal's triangle, which are 1, 5, 10, 10, 5, and 1, and place them down. And next to them, I'm going to put an x with a room for an exponent, and a 3 with a room for an exponent, and then a plus sign. And then an x, because the x is in here, with a room for an exponent, the 3 because the 3 is second, and room for an exponent, and then a plus sign, and then an x with room for an exponent that I'll put in a bit, a 3 with a room for an exponent, and then a plus sign, an x with a room for an exponent, a 3 for a room for an exponent, and then plus sign, and then after the 5, an x, room for an exponent, a 3, room for an exponent, and then a plus sign, and then for the 1, an x, a room for some exponents, and a 3, and a room for some exponent. These are going to be all 6 terms in the expansion. And for the exponents, I start the x with the power that's given, and I start the 3 at 0. I always make my exponents add to 0, add to 5. And then as I move left, I subtract 1 from the x's exponent and add 1 to the 3's exponent. So the next exponents, the x is going to go from 5 down to 4. The 3's exponent's going to go from 0 up to 1. And then I'll do the same for the next. The x's exponent's going to move down from 5 to 4, now to 3. The 3's exponent's going to go from 0 to 1, now to 2. The exponents will always add up to 5 because this is a 5th degree binomial. And then I'm going to go 2 for the x, 3 for the 3, 1 for the x, 4 for the 3, 0 for the x, 5 for the 3. So the first term in my expansion is going to be 1 x to the 5th times 3 to the 0, and anything to the 0 power is 1. So in this expansion, the first term is just going to be x to the 5th. The second term is going to be plus 5 times x to the 4th times 3, because 3 to the first power is 3. I multiply the 5 and the 3, and I get 15 x to the 4th. The third term in my expansion is going to have a 10, an x cubed, and 3 squared is 9. I'm going to multiply the 10 and the 9 and get 90x cubed. The fourth term in my expansion has the 10. It's going to have an x squared, and it's going to have a 3 cubed, and a 3 cubed is 27. I'm going to multiply the 10 times 27 and get 270. I could stop, or I could go further, because this is going to be my answer, but I'll go further just for the heck of it. The fifth term in my expansion is going to be 5 times x to the 1st times 3 to the 4th, which is 81. 5 times 81, I think, is 405. That's the fifth term. And the last term is going to be 1 times x to the 0, which is 1, times 3 to the 5th, which is 243. The last term is going to just be a plus 243. So that's all 6 terms in the expansion, but this only asks me to find the fourth term. So first, second, third, fourth. My answer to 18a, the fourth term in the expansion of x plus 3 to the 5th, is 270x squared. Double check that, because that's kind of a monster problem. Do the same thing now for part B of 18. I use the binomial theorem to expand, and I'm only going to need the second term. I'm not going to do all, in this case, 5 terms. You always get one more term than there is exponents. This would have 5 terms. I'm going to write Pascal's triangle down. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Just kind of adding 1 and 1 is 2, 1 and 2 is 3, 1 and 2 is 3, leaving the 1s on the outside. I stopped when I got to the 4 because this is a fourth power. So my terms are going to have a 1, and then a 4, and then a 6, and then a 4, and then a 1. And then I get an x with an exponent, a 2 with an exponent, an x with an exponent, a 2 with an exponent. And I can do that all the way down, set up for every term. But I only need the second term, so I'm not going to get as crazy this time. The exponents start would be, I always start the first with the exponent in the problem. So this x gets a 4, the 2 gets a 0, and then I'm going to add 1, subtract 1. So go from 4 to 3, from 0 to 1, from 3 to 2, from 1 to 2, from 2 to 1, from 2 to 3, and from 1 to 0 and 0 to 4. My exponents always have to add up to 4 because this is a 4th degree polynomial. And the second term in my expansion is this. That's the only one I'm going to find because it's the only one I need. It's going to be 4 times x cubed and times 2 to the first, which is 2. So my answer to this is going to be 8x cubed. Again, check it to make sure I'm not sending you down the wrong path. 19 isn't particularly hard, but it would be if you don't know the trick to absolute values. So absolute values aren't particularly hard when there's a number, but when there's a variable, it's hard. So this is just a quick review, and it might be actually new to you, of absolute values, because you have to understand absolute values theoretically to do this problem. So in general, if you looked at the absolute value of 3 and the absolute value of -3, I'm assuming most of you understand how to drop the absolute value signs. The absolute value of any positive number is just that number without the absolute value sign. And most of you, if you were asked to write down the absolute value of -3, you'd write 3. Technically, the absolute value of -3 is the opposite of -3, and the opposite of -3, we write like that. That's the opposite of -3, and the opposite of -3 is +3. You generally don't show that step, but it's going to be important when we're dealing with variables because they work differently than numbers. So for the absolute value of x, I can't just say the absolute value of x is x. I'd like to say that, but I don't know if x is holding a place for a positive number or if it's holding a place for a negative number. So for the absolute value of x to equal x, this assumes that x is representing some number that's bigger than or equal to 0. So if I know for sure that x is standing for a number like 3 or 7 or 1700, I can just drop the absolute value of x and say that it's x. However, if this was like a scratcher's lottery ticket and I could scratch underneath this to see what x equals, and underneath this x I saw -5, well, this means x is holding the place for a negative number. I can't say the absolute value of x equals to x. The absolute value of x in this case will be the opposite of x. That is, when x is less than 0, or it assumes x is less than 0. So for variables, you can't just drop the absolute value unless you know that the absolute value is holding the place of a positive number. If the absolute value is holding a place for a negative number, then you have to find the opposite of what's under the absolute value, and the opposite of x is -x. So it looks to me like I'm making an absolute value negative. I'm not. I'm turning a negative number positive by finding its opposite. That's the trick for the next question, number 19. And it's a little subtler. And I think on both versions of the Accuplacer test, they had tricks with absolute values, and this was the big trick. So I look at this, and I don't know if x plus 1 represents a positive number or a negative number. But I do know that for any absolute value that this is going to be true, that the absolute value of x plus 1 will equal x plus 1 when x plus 1 is a positive number, or 0. And that's when x is greater than or equal to negative 1. And I know that the absolute value of x plus 1 equals the opposite of x plus 1, which is negative x minus 1, when x plus 1 is less than 0, or when x is less than negative 1. So for this absolute value, it depends. How I reduce the absolute value depends on what the values of x are in the problem. If x is bigger than or equal to negative 1, then I can just drop the absolute value sign and be done with my absolute value. But if x represents a number less than negative 1, then this is holding the place for a negative number, and to drop the absolute value, I need to find its opposite. If I look at the problem write-up, I'm told that this x is holding the place of any number between negative 5 and negative 3, and negative 5 and the numbers between negative 5 and negative 3 aren't bigger than negative 1. They all satisfy that they're less than negative 1. So this is the version of the absolute value that I needed this trick twice, both times I took the Accuplacer. And the problems are not the same problem, but this is a trick that you need. So I didn't want to give Accuplacer's problems away, but I want you to be exposed to that trick. So the answer to problem 19a, when x is between negative 5 and negative 3, the absolute value of x plus 1 equals negative x minus 1. See my writing deteriorating, sorry about that. My students get used to it, but you're not my students, so I should probably work on doing better. So same thing for problem part B of 19. The absolute value of x minus 3 only equals x minus 3 when x minus 3 is greater than or equal to 0, or that is when x is bigger than or equal to 3. And the absolute value of x minus 3 equals the opposite of x minus 3, which is negative x plus 3, when x minus 3 is less than 0. That is when x is less than 3. And same instructions, I was told in this problem that the x's are holding a place for some numbers between negative 5 and negative 3, and because negative 5 and negative 3 fit x is less than 3, then this is holding the place for a negative number, and that needs to be my answer. So my answer to part B is going to be negative x plus 3. Again, I should be checking my work because you hate to have a wrong answer on a video forever. So perfect and perfect. If you want to take calculus, like Math 220 calculus, that's calculus that has trig in it, then you can't just test into it without ever having trig and hope to pass. You might be able to score high enough on the test to qualify for calculus, but if you've not taken trig, calculus will be a disaster. So even if you test high enough, please, take trig before you take calculus. So, tricky problem, trig problem, For trig, there's just some things you should know for trig, and I don't remember a lot of trigs. I don't teach it that much, but you should know a basic cosine graph, probably what it looks like. Goes from 0 to 2 pi on the x-axis, goes from -1, +1 to -1 on the y-axis. It's not a stellar graph, but if you've taken trig, that's stamped into your brain. And you should probably know the cosine of some basic values. The cosine of 0 degrees or 0 radians is 1. The cosine of pi over 6 radians, which is the same as the cosine of 30 degrees, which is the square root of 3 over 2. Should know the cosine of pi over 4, which is the same as the cosine of 45 degrees, is the square root of 2 over 2. Again, if you've never taken trig, this would just be gibberish. But if you've taken trig, this should be something that, at least if you don't remember it, it comes back pretty quickly. So for cosine, I think you got to know those. It'd be nice to know the entire unit circle, but that's probably kind of a minimum of what you should know for cosines. And then for sines, you should remember a generic sine graph starts at 0, ends at 2 pi, goes up to 1, down to -1, and then you should know sines for the same values. Sine of 0 degrees, which is 0 radians as well, is 0. Sine of pi over 6, which is in radians, is the same as sine of 30 degrees, which is a half. Sine of pi over 4 is the sine of 45 degrees, is the square root of 2 over 2. The sine of pi over 3, which is the same as the sine of 60 degrees, is the square root of 3 over 2. And the sine of 90 degrees, which is the sine of pi over 2, is 1. And I messed up here. Cosine of 90 degrees, which is there, is 0. So hopefully you caught that before I flip this page, and you can't talk to the video, but hopefully you realize I was being stupid there. And that's a +1 for the sine of 90 degrees. That I should know. And I'm going to make my best stab at explaining the next problems. They're kind of tricky. And a lot of times when you solve in a trig class a problem like I'm about to do, you'll get every answer that works between 0 and 2 pi. So you might get, start drawing reference triangles and get maybe 2 or 4 solutions. This particular problem very specifically only wants first quadrant solutions. So this little blurb here that says assume x is an acute angle, that means even though I understand that cosines and sines are cyclical and there might be multiple solutions between 0 and 2 pi, I only want solutions in the first quadrant. So what I'm going to do is I'm going to solve cosine squared x equal to 1/2 for x, and then answer the question to find cosine of 2x. So first I'm going to find what x equals, and I could do it in degrees or radians, whichever I'm most comfortable in. It kind of doesn't matter. So if I'm working with cosine squared x equals 1/2, to solve this, I'm going to square root plus or minus square root. On the left side, the square rooting is going to cancel out the squares and just give me cosine of x. On the right side, I get really plus or minus the square root of 1 over the square root of 2, if you want to think about it that way, which is plus or minus 1, because the square root of 1 is 1, over the square root of 2. And I'm going to rationalize this by multiplying by the square root of 2 over the square root of 2. And this is going to give me cosine of x equals plus or minus the square root of 2 over 2. This is going to give me the ability to solve for x's. There's actually 4 different answers to this if you want to consider the whole 0 to 2 pi or 0 to 360. But for our purposes, we're only considering angles in the first quadrant, and the angle in the first quadrant that has a cosine of square root of 2 over 2 is 45 degrees, or pi over 4. I like degrees better, so I'm going to say my answer to this is x equals 45 degrees, realizing I'm limiting myself to the first quadrant. Again, if you took trig, 45 degrees, 135 degrees, 225 degrees, and 315 degrees would all be solutions to this problem, but not all solutions in the first quadrant. So now I know that x is 45 degrees. I'm going to take this value of x and plug it into the find cosine of 2x. So the cosine of 2x is going to be the cosine of 2 times 45 degrees, which is the cosine of 90 degrees, and the cosine of 90 degrees is 0. So these are things, if you don't have them memorized or can't get them from a unit circle or a basic graph, then you're going to stumble through the trig questions, and that just will be what it is. So my answer is the cosine of 90, and the cosine of 90 is 0. So the answer to this is the cosine of 2x equals to 0. It's kind of a monstrous just way to jump into trig, so sorry about that, but that's what they do on the Accuplacer. They just kind of jumped into some tough things. So 20b is the same setup, except it has sines instead of cosines, but the algebra is almost going to be 100% identical. So for 20b, I'm going to start off and I'm going to square root, take the sine squared of x equals plus or minus the square root of 1/2. On the right side, the square root is going to cancel out the square and give me the sine of x equals plus or minus, and this is exactly the same radical as part A, so that's going to reduce to the square root of 2 over 2. So I'm going to say the sine of x equals plus or minus the square root of 2 over 2, and I only want the angle in the first quadrant whose sine is the square root of 2 over 2, and that's 45. The 45 degree angles, the sines and the cosines are the same, well, except for sines in some quadrants, but the answer for x in this part is the same, 45 or pi over 4, that it was in the last part. So I'm going to say x equals 45 degrees. And again, this is assuming that x is only a first quadrant angle. If I was allowed to do, more quadrants, then I get more solutions. Now I can find the sine of 2x. The sine of 2x is going to be the sine of 2 times 45, which is the sine of 90. And again, that's one I just happen to have memorized. The sine of 90 is going to be 1, because the sine graph at 90 degrees is up at 1. So my answer to this problem the sine of 2x is going to be 1. Again, I should absolutely check these last two. For 20a, I put 0. For 20b, I put 1, so I feel good about those. For 21, it's a tough problem because, again, you may have not seen anything like this for a while. To do problem 21, I need to expand the given logarithm into 2 logarithms. So first I'm going to use the product to sum rule. You can call it the sum to product rule. Depends which direction you're working. To rewrite this logarithm base 10 of x cubed times y as the sum of 2 logarithms. And this is kind of just the reverse of what we did earlier. So there's a logarithm rule that says if you have multiplication inside an logarithm, that you can expand that logarithm into multiple logarithms if each argument or each factor is put in its own logarithm. Put parentheses there. I probably really didn't need the parentheses around the x cubed and the y, but it's fine to have them there. Now I'm going to use the power to product rule. And again, this is backwards of what we did a little bit ago. Power to product rule. On the x logarithm. Because the power to product rule says that if inside a logarithm you have an exponent, you can drag that exponent out in front of the logarithm, and that would be equal to the logarithm that had the exponent in it. What I've done is I've expanded and rewritten the logarithm to use the tools that I'm given. Now I'm going to replace the log of x with 2 when I do that, I get 3 times 2, and I'm going to replace the log of y with 5. Because I'm told that the log of y can be replaced with 5 and that the log of x can be replaced by 2. So 3 times the log of x can be replaced with 3 times 2 because log of x can be replaced with 2. Plus log of y can be replaced with plus 5 because log of y can be replaced by 5. Now I'll just simplify this. This is going to be 6 plus 5. And my answer to 21a is just going to be 11. Do the same thing for 21b. So again, I'm going to expand. So I'm going to expand using the product to sum rule. So the logarithm of x squared y cubed can be expanded to the logarithm of x squared plus the logarithm of y cubed. Notice I didn't put the parentheses. It's probably nice to have the parentheses, but often when you just have a single variable for your argument, you don't throw the parentheses in, and it's okay. And now I'm going to, oh heck, I'll put them in here just because maybe you like those, but they're not really necessary. Now I'm going to rewrite using the power to product rule. And get 2 times the log of x plus 3 times the log of y. Almost done. Now I'm going to replace log of x with 4 and make this 2 times 4 because I'm told the log of x can be replaced with 4, and the log of y with 3. So I can make this 2 times 4 plus 3 times 3 because the log of x can be replaced with 4, log of y can be replaced with 3. This is 8 plus 9, so my answer is going to be 17. 2 times log of x. This is troubling because when I look at my key, I see 21b, I'm supposed to say 18. I don't see a mistake, but I will, anytime I get an answer that I don't think is wrong, I might rework my problem. But I think the answer is supposed to be 17. Let me rework this problem, write it down again, because I can't find my mistakes sometimes. So if it says if log of y equal to 3, log of x equal to 4, find log of x squared y cubed. So I'm going to expand it. This equals the log of x squared plus the log of y cubed. Now I'm going to use the power to product rule, make this 2 times the log of x plus 3 times the log of y. In place of the log of x, I'm going to put the number 4. In place of the log of y, I'm going to put the number 3. I'm pretty comfortable that the answer is 17, and that when I wrote my key, I don't know what I was doing, but I believe the answer to 21B is 17. I'll double, triple check myself before I post this video online. I assume it's right. Okay, 22. Sines and cosines are cofunctions of each other, and that's what we have to remember. There's some cofunction identities. We have to remember that the sine of x is the cosine of 90 minus x. Similarly, the secant of x would be the cosecant of 90 minus x, because secant and cosecant, secant, cosecant are cofunctions. Similarly, tangent of x and cotangent of x are cofunctions. So in this particular problem, 22a, because sine and cosine are cofunctions, I know that this angle is that angle minus 90. So I know that 50 is 90 minus x. If I want to solve this for x to get my answer, I'm going to minus 90 from both sides. That's going to give me minus 40 equals to minus x. And then I'm going to divide both sides by a negative 1. And I'm going to get my answer of 40 equals to x. I'm checking it without you seeing me check it, and that's the answer that I have written down. Do exactly the same thing for 22b. As long as you have cofunctions, the angle from one to make them equal, you do 90 minus the other. And tangent and cotangent work that way. They're cofunctions. So I know the tangent of 20 is the cotangent of 90 minus x. Solve it the same way. I'm going to minus 90 from both sides. And I get minus 70 equals to minus x. And then divide by minus 1, divide by minus 1. I get my answer of x equal to 70. Last problem. So, assuming you're going to sit through me doing this, if you could do me the biggest favor, if after you take the placement test, if you find my review was horribly unhelpful or extremely helpful, let me know so I can know whether I need to tweak this or leave it. Like I said, it's probably impossible to prepare you 100% for the Accuplacer test. The best we can do is just kind of get your mind thinking mathematically again. But I think it's impossible to show you everything that's possibly on the test, because I don't even know what's all possible. But if you have any strong opinions about this review that I did, shoot me an email. So it's john.grima@gccaz.edu. And I'll take your emails into consideration in terms of, whether I scrub this and try to write something better, or if this is kind of okay. Again, my goal is not for you to be able to do every problem on that test. No student should probably be able to do every problem on that test, or they wouldn't need to even take calculus, more than likely. So let me know. So 23 is tough because it involves remembering both the quadratic formula and factoring cubes. I teach factoring cubes differently than I'm going to show you now, just because I know the way most teachers show factoring cubes. So for 23a, I have to first factor, and then I'm going to need to use the quadratic formula. And this is a tough problem. Might be one that I punted on if I, didn't really want to sweat over this. So for the factoring, there's a formula for factoring sums of cubes. That you kind of need to remember. And that formula is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. I started teaching at GCC in 1994, and my very first semester at GCC, I taught this formula wrong. I had a 2 in front of the ab, and my students learned it wrong, and no, I don't teach it wrong anymore. In this problem, to use the formula to factor x cubed plus 8, x cubed is in a nice form. 8 isn't in a nice form. 8 is 2 cubed. So to factor x cubed plus 8, I'm going to make the x in the position of the a and rewrite the 8 as 2 cubed so that the b is going to be 2. So this is going to factor into x plus 2 times x squared minus x times 2 plus 2 squared. And that's going to equal to x plus 2 times x squared minus 2x plus 4. So I'm going to take that and put it right in line with my problem. I'm going to say this problem can be rewritten as x plus 2 times x squared minus 2x plus 4 equals to 0. Now I'm going to set the factors equal to 0. When I set the x plus 2 equal to 0, I minus 2 from both sides and get x as minus 2 for one of my answers. When I take the x squared minus 2x plus 4 and set it equal to 0, I'd love to factor it, but it doesn't factor, so I have to use the quadratic formula. And in the quadratic formula, the a is going to be 1, the b is going to be negative 2, the c is going to be 4. So this problem requires you to remember how to factor cubes, and it requires remembering the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So getting back to this side, I get x equals fraction negative from the formula and then negative 2 from the b, and then plus or minus square root and then negative 2 squared minus 4 times 1 times 4 all over 2 times 1. And then under my radical, that's a 4 minus 16, which is negative 12. So this is going to give me, in the numerator, this double negative goes positive, which gives me a 2, and then plus or minus the square root of negative 12 over 2. Negative 12 is going to reduce to have an I, and because the square root of 12 is the square root of 4 times the square root of 3, the square root of 4 is 2, the square root of 12 is going to be 2 square root of 3, but because of the negative part, I need to pick up an I. So this is going to equal 2 plus or minus 2 square root of 3i all over 2. And because the denominator goes into the 2's outside the radical on both sides of the plus or minus sign, in the numerator I need to divide all those things by 2. 2 divided by 2 is 1 each of the 3 times. I've created a fraction without a need for a denominator because there's a 1 in my denominator. I'm about ready to write my answer. So my answer to 23a is this lonely negative 2 that I kind of neglected. And then this is going to be 1 plus or minus, I don't need to write that 1 anymore, and then I'm going to write the square root of 3i. And exactly what I had there. I should probably check my other answers to make sure that, yes, 40 and 70 were nice answers. One last problem, and hopefully that makes you more prepared for the Accuplacer college level math than you were without me. And then again, go to the Accuplacer site and try their free test too. I need a different formula for part B here. To do this, I need to remember the formula that says a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. In this problem, I need to think of it as x cubed minus 3 cubed, because 27 is 3 cubed, so the x is working like the a, the 3 is working like the b. This will factor into x minus 3 times x squared plus x times 3 plus 3 squared, which is going to give me x minus 3 times x squared plus 3x plus 9. And I'm going to take this and write it under my original problem. So my original problem can be improved upon. I can say this is the same as x minus 3 times x squared plus 3x plus 9 equals to 0. And then I'm going to go x minus 3 equal to 0 and x squared plus 3x plus 9 equal to 0. For the x minus 3, I just add 3 to both sides and get one of my answers, x equal to 3. Next part is prime. I'm going to use quadratic formula with a equal to 1, b equal to 3, c equal to 9. I'm going to go x equals to negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4ac, which is 4 times 1 times 9, all over 2a, which is 2 times 1. You'll notice I didn't put the b in a parentheses. I only put the b in a parentheses when it's negative. If it's positive, you don't need the parentheses. Under my radical, you have 9 minus 36, which is negative 27. So this is going to give me x equals negative 3 plus or minus the square root of negative 27 over 2. And then for 27, you get that negative 27 is going to give me an I. And then the square root of 27 is the square root of 9 times the square root of 3, which is 3 square root of 3. So I can rewrite this as x equals negative 3 plus or minus, and then 3 square root of 3 for the positive 27, and I for the negative 27, and over 2. That can't reduce because the 2 doesn't go into any of the 3's in the numerator. So I'm going to just say this is part of my answer, and next to it write the other part of my answer, which is the 3. So my answer for the last problem is 3, then negative 3 plus or minus 3 square root of 3i over 2, which is perfectly that. All right, so that's everything. Go through this video, a couple of times, or maybe try to do my review without watching the video. It should definitely help you just thinking right for the Accuplacer test. And also go to the Accuplacer website and try their review, because that's going to help you a bunch too. Because I kind of didn't try to make my stuff intersect with that. thinking that you'd be able to get, you know, that from poking around YouTube and trying their review as well. All right, well, let me know again how it did or didn't help you, because I need to know. Thanks.